Now, what is the geometrical intuitions behind the k nearest neighbor? Okay, so let's see this in these lectures. So these intuitions we will simply discuss through a toy example. Suppose let's example, and also discussing the examples we have assumed something, that is, let's take our classifier is a sample. We are want to build our classifier, it is a binary classifier. Suppose let's take, because of simplicity, and this example we have taken in 2D space. By if we just understand this thing in 2D space by simply using the linear algebra concept, we can easily extend this 2D space to a high dimensional space. Okay, so first let's take a binary example. Binary classifier, let's take our classifier is a binary classifier. Okay, first assume it. So in binary classifiers we have two kind of data sets, that is, let's take, we are using blue color here for positive data point, and I am using here red color for negative data point. Okay, and this kind of binary classifier we have seen. If you just write this thing in, if let's take our data sets will be like this. Let's take our data set is like this. D is equals to xi, yi. Xi means our features vector, yi means the corresponding output of this features vector. Here suppose let's take our data, number of data sets in our training data sets is equals to n. So I would be, our I will be 1 to n, such that we are considering the in 2D, just again writing, I am just using the 2D toy example. Okay, simple, here I am considering the 2D toy example. So our xi features vector will be lie in 2D space, and our yi is 0 and 1. 0 for what? 0 for, I am taking the 0 for here I am 0 taking for negative data points, I am using 0 for negative data points, and I am using 1 for positive set of data points. Positive set of data. Okay, this is simple our data frame. Now let's take an example. Suppose let's take our positive data points would be like this. Like this, and there is something here also, some type of positive level data points, and our negative data points will like this. Like this, and it is like this, our, this is our negative set of data points, this is blue points are positive. And suppose let's take suppose we have one data sets negative points in a positive set of data points, and one positive points like that. Okay, suppose this is our simple data frame. Data, if we just plot our data, it's simple, it's look like this. And the geometric intuitions, the main concept of this k nearest neighbor is so we have find, suppose before going to, suppose let's take, just I'm using here for query point. Suppose let's take our query data point is like here. We are interested to find the class level of this point, and also this point we call the query point. Suppose let's take our query point is xq, let's take our query point is xq. We are interested to find its class. What will be the class of this point? We are interested to find. So simple, we have a query point, we are have to find its corresponding class level. Okay, this is simple task. This is our simple. Now the geometrical concept is here. We have to first is close to. We have to find the points that is close to our xq. That is neighbor of the. We have to consider the points that is neighbor of this point. Suppose let's take here I am using simple. I am considering this point is the neighbor point of this one. Suppose let's take this point. Just see the boundary points. I'm just considering. Suppose let's take these 4 points are the closer point to the xq. So we have to first have to find the closer point. Closer points to xq. We are interested. Okay, this is the here sample we have seen, and also in our data sets we know the class level of these points. So according to the class level of this point, if we have seen the neighbor points class level of the edge neighbor points is positive here. Okay, this is positive data, positive. So we can easily conclude that our xq point, class level of the xq point may be to be positive. Okay, this is the simple concept. So this is the simple geometric concept. We have to find the closer point of our query point and corresponding the corresponding the class level of the closer point. We have to decide it what will be the class level of this query point. This is the simple here from this example. Just if you see this example, we can conclude that our query point class level of the query point will be blue, means positive. Okay, positive means simply blue. I think you understand this thing. Why we are taking here this just from this example. Okay, guys, we are using the closer point of our query point. So what we have doing this is we just conclude this. We have our data sets. From our data sets we are simple interest to find a model, machine learning model. Let's call our model is f, and from our data sets we can we have a query point. From this query point, by using this simple f, we have to decide it this query point will be positive or this is negative. Here this thing we have done, because simple first we have consider our algorithm is this is the simple closer to xq. This is our f, closer to xq. By simple using the data sets d to find the closer point of this xq point, we have seen these 4 points are, let's take these 4 points are the closer to our query point. And since this closer point is blue color, means it is a positive data set of data points. According to the based on this, we can conclude that our query point class level will be positive. So this thing we have. Okay. Now the thing is that, sir, how to choose the what number of closer point we have to? So you may ask simple questions. These be natural questions, sir. This point may be closer, this point may be closer, this point, also this point may be closer, this point may be closer. So how much we have to choose? So this is the questions. Okay. So to avoid this thing, here we are using the concept of hyperparameter. Simple. So now the question is there how to choose the proper neighbor of the query point. This is the main question. So to avoid this problem, here we are introducing the concept of k. K means here hyperparameters. According to the k, we have decides how if we choose k is 3, simple we are choosing the 3 neighbor point, 3 closest point. If we choose k is equals to 4, we have chosen the 4 closest point. If we choose k is equals to 5, means we have chosen the k closest point of the query point. This is the crack of the concept. So suppose let's write down this. So we have to find k nearest neighbor. K nearest points to x cube. Okay, in our data set D. Means D means simple as usual. Here D means training data sets. Okay, suppose let's take here what we are choosing. Let's take here we are choosing k is equals to 4. Means we have chosen this point, this point, this point, this point. This is the 4 closest point. Here I have chosen. So let k is equals to 4. That we have seen from the above picture. That one. Now we have chosen the k point. Now how we will decide? Now the decide it will be here. Suppose let's take this point is, suppose let's take our this point is x1, this is x2, x3 and x4. Okay, let's choose. We have finding here the 4 carry x1, x2, x3 and x4. We have got this 4 neighbor point, means 4 nearest neighbor from our query point x cube. For our query point x cube, this x1 x2 is the 4 nearest neighbor, and corresponding the 4 nearest neighbor we have the output. This for this x1 we have output, that is actual output is x1 from our data sets. From our data sets we will easily get this thing. For x2 we have y2, for x3 we have y3, for x4 we have y4. Let's take this is our actual output. Now in second step what we'll do? In second step we'll do that. In second step among these four output vectors, so we have chosen the majority vote. What is the majority value of these 4 things? So in second step we will choose among these y1, y2, y3 and y4 the majority vote. Okay, according to this majority vote we will choose what will be our class level. Okay, so here is the one main problem we have seen. Here the main problem is that we see, suppose here what we choose, here we have choose that k is equals to 4, means k is equals to here even number. Suppose let's take, suppose it's 3 of them is positive. If suppose let's take, if 3 of them is positive and 1 is negative, so what will be the majority vote? So majority vote will be positive. Suppose let's take our suppose let's take 3 of them is negative and 1 is positive, so what will be the majority vote? Majority vote will be negative. So according to that, means according to that, if majority vote is positive, so our class level of the query point, so here yq will be positive data sets. If our majority vote is negative, our query point is negative, so what will be the output? It will be negative. Well, suppose the main problem is that if we choose here, what we choose? Here we choose that k is equals to even number. Suppose if our data point is like that, 2 points is positive and 2 point is negative, so what will be the negative point? It may be negative or it may be positive, so we got a confusion here. So what will be the actual class level of a query point? So to avoid this problem, here we can avoid to take our parameter value, that is k value, in even. Here always we are taking our parameter value as odd. So always we have taken our k is equals to odd. Always we have considered k is equals to odd. Okay, so suppose if we have considered k is equals to odd, then what will be the value? Suppose let's take taken k is equals to odd and we got the 3. Suppose let's take here k is equals to 3. Let's take for example, let's take k is equals to 3. K is equals to, so we got the output y1, y2, y3. Okay, and now we have to choose its majority vote. Okay, so if it may be positive or negative, then we have no problem, it will be positive. If it is negative, positive, then we have also no problem, it will be negative. If all are positive, then also we have no problem, this is trivial case, it will be positive. If we have all the negative, then also no problem, so it will be negative. So how much cases? If we just I think all the cases I have considered, positive, negative. Okay, I think all this type of case we have seen. So if we have chosen k is equals to what, then we have no problem. So actually what we will doing in k nearest to neighbor. So we have taken a query point. First job is we have taken a query point, and simple we are deciding knn what will be our k value, and we always consider to take our k as odd value. We will find the knn. Simple, k is odd. We will find the knn of our xq. Suppose let's take this knn of xq is x1, x2 suppose xk, and we will find the corresponding outputs of the k closest point of xq. So let's take the output of the k closest point is y2, y1, y2 up to yk, and among these k point we have simple find its majority vote, and according to this majority vote we will decide what will be our yq. This is the job actually. What we have done, what we have done in xq, in k nearest neighbor. Sorry, k nearest. I think this is the simple geometrical idea. Simple, we have taken a query point and we will find the knn, okay, from our data sets, and according to our data sets we will finding the majority vote of this knn point, and according to this majority vote we will simply decide it what will be the output value of our query point. This is the simple thing. Okay, this is simple geometrical intuitions of the k nearest neighbor. I think using this simple toy example, the geometrical intuitions behind the k nearest neighbor is all about clear.